This is the story of the long-tailed beaver and how it becomes a regular beaver who chops down trees. Before the long-tailed beaver appears, a few things have to happen. Firstly, a tree must fall down to activate the magical beaver hole. The magical beaver hole will then shoot out a long-tailed beaver who, on contact with the ground, loses his tail and becomes a regular beaver. This now regular beaver will then see the fallen tree and get to work. First, he'll look at the tree and see if there's any large branches that will help him hold on. Luckily, this tree has just the branch he's looking for. He'll then grab a hold of the tree with his left and right hand and chew away. So, what's with the beaver analogy? What does it mean? Do beavers really shoot out of magical beaver holes and chop down trees with specific branches? Yes, and I'll show you how. It all started off with the tree falling down, activating the magical beaver hole to then spit out a long-tailed beaver. What the hell does this mean? Well, the tree falling down is analogous to food particles entering the stomach, and the magical beaver hole represents the chief cells which secrete or release pepsinogen, which is the long-tailed beaver. Stay with me here. I then said that once the long-tailed beaver had hit the ground, it would convert to a regular beaver through the loss of its tail. This is analogous to what happens in the stomach when pepsinogen is released. Upon contact of pepsinogen with gastric acid, it loses a 44 amino acid long tail and converts to its active form known as pepsin. The active enzyme pepsin represents the regular beaver. The regular beaver is then said to look at the fallen tree and try to find any large branches that will help him hold on. Once he finds his branch, he grabs a hold of the tree with his two hands and chews through the tree until it is cut in half. Now, if you looked closely at the animation, you would have noticed that our beaver had a hand tattoo that said ASP32. ASP32 stands for aspartate 32, which works in conjunction with aspartate 215 on the pepsin molecule to hold a polypeptide in place to be cleaved. The tree branch that helps the beaver hold on represents the hydrophobic aromatic amino acids that pepsin preferentially cleaves adjacent to. These amino acids may be phenylalanine, tyrosine, or tryptophan. Now that we have a basic understanding of what pepsin does, let's look more in depth into the mechanistic reaction between it and a polypeptide. The first thing that you should know is that this reaction consists of three main steps: the nucleophilic attack of an activated water molecule and formation of a tetrahedral intermediate, nitrogen conversion, and fission or breaking of the sessile bond to release the product with new carbon and nitrogen termini. Firstly, pepsin binds the polypeptide near an aromatic amino acid, which is stabilized in a hydrophobic pocket, much like the chymotrypsin mechanism discussed in class. The active site of pepsin consists of aspartate 32 and aspartate 215, as well as a water molecule that is hydrogen bonded to them. Upon the formation of hydrogen bonds with the polypeptide, the water molecule is activated and attacks the carbonyl carbon exposed by the polypeptide, kicking off a bond to create an oxyanion. The negatively charged oxygen will then steal the hydrogen from aspartate 32, leading to the formation of another oxyanion. This newly formed oxyanion will then reclaim its hydrogen, causing the formation of a carbonyl and breaking the carbon-nitrogen peptide bond. This negatively charged nitrogen will then attack the hydrogen of aspartate 215, leading to its stabilization. This also regenerates the initial condition of the aspartates and allows them to be ready for the cleavage of another polypeptide. Thanks for watching, and I hope you learned something about beavers, pepsin, and of course, magical beaver holes. See ya!